Today we're going to be talking about adding and subtracting rational expressions, and I'm just going to kind of refresh your memory on how to do these few things that are listed here, finding least common denominators and adding and subtracting just simple fractions. So we're going to start by talking about the least common multiple of these three numbers, 9, 18, and 24. And what that means is what's the lowest number that all three of these numbers divide into evenly. So whenever I figure out least common multiple, I usually start with the highest number and just start listing some multiples of it. So 24 times 1 is 24, 24 times 2 is 48, and just continue. And I wouldn't write too many of them because you usually don't have to go too far in order to find the least common multiple. So then 18, I'm going to list some multiples of that. So 18 times 1 is 18, times 2 is 36, times 3 is 54, times 3 is 72. And that's what we're looking for, are numbers that the lowest number that they have in common. And hopefully you know that 9 goes into 72. So it looks like 72 is the winner for that question. That's the least common multiple of those three numbers. So that when we go to add and subtract simple fractions, like you see here, that's what we're looking for the denominator, because in order to add or subtract fractions, you absolutely positively have to have a common denominator. And so when I'm looking at 4 and 6, hopefully you can kind of do this, maybe not as involved as example 1. Instead of listing them out, hopefully you can just kind of think about it. And I know that 6 times 2 is 12, and 4 also goes into 12. And so 12 is going to be our common denominator here. And so what we need to do is change these fractions around, and hopefully this looks familiar from, I don't know, grade school maybe. So I'm going to multiply 6 by 2, but whatever you do to the denominator, you have to do to the numerator. So I'm also going to multiply the numerator by 2. Over here in the first fraction, I have to multiply the 4 by 3 to get 12. So I'm going to do the same thing to the numerator. And so what I'm going to get is 9 over 12 plus 10 over 12. And when you add fractions or subtract fractions, you're just, as soon as you get that common denominator, you're just combining the numerators. So I end up with 19 over 12. And there's nothing to reduce there. So now we get just a little bit more involved, and I need to come up with a common denominator for these two fractions. So I'm just going to kind of see what they have in common. I can see that the second fraction doesn't have any a's in the denominator. However, they both have a b in common. So it looks like I'm going to need to get b squared because that's the least common multiple for the b's. And it also looks like I'm going to need to have an a squared in both and also a 5 in both. So my least common denominator is going to have to be 5a squared times b squared. And so that's my goal to get for both of these. I'm just going to write this down here. And so really what I'm going to do is look at this one and see, okay, well, what am I missing? To get to here, what do I have to multiply this denominator by? So it looks like I need one more b, and I need that 5. So I'm going to multiply this denominator by 5b. I have to do the same thing to the numerator. Over here, I'm just missing the a squared. So I need to multiply this denominator by a squared. I'm going to do the same thing to the numerator. And so what I get in the numerator here is 25b. And I'm going to bring the subtraction symbol down. And over here, I'm going to get 7a to the third power. And now we can go ahead and combine those by just combining the numerators. And there's really nothing that I can combine there because they're not like terms. So I'm just going to have 25b minus 7a to the third power all over 5a squared times b squared. So here's the procedure. We're going to get a little bit more involved with this. So we're going to factor the denominators, look for the shared factors to keep in the denominators, and multiply each side but by anything that the denominator does not have, and then combine the numerators. So go ahead and pause this, write this procedure down. You're going to need it in class tomorrow, and we're going to continue with another example. So in number 4, I'm going to factor anything I can in the denominators. Well, as you can see in the first one, there's nothing to factor. However, in the second one, there is. This is the difference of two perfect squares. So I'm just going to rewrite this. Try not to get it all jumbled by trying to factor all up here. Just rewrite it. So instead of y squared minus 9, I'm going to write it as y plus 3 times y minus 3. And now I'm just going to look to see what does this denominator have that this denominator does not have. And hopefully you can see that it's missing a y minus 3. And so I need to get that common denominator. So what I'm going to do is multiply this denominator by y minus 3. And I'm going to do the same thing to the numerator. Anything you do to the denominator, you have to do to the numerator. And don't forget, we have to distribute this y. And so the new numerator here is going to be y squared minus 3y. And I'm just going to bring this down, the 6y. And since I have a common denominator now, I can go ahead and combine these. And again, when you combine them, you're just keeping the denominator and you're combining the numerator. So I have y squared minus 3y plus 6y. I can go ahead and combine like terms there. The negative 3y and the 6y would give me a positive 3y. So this is going to be y squared plus 3y. And I can actually reduce this a little bit. So I can factor the numerator here. So some of these take a little while, but it should be pretty straightforward after you practice with a few of these. So now after what we were talking about the other day, I can go ahead and reduce this by dividing out the common factors here, the y plus 3 with the y plus 3. And I get y over y minus 3. Most likely if this is a multiple choice question, they're not going to have this form, they're going to have this form. So you have to realize that you can reduce it from there. All right, here's the next one. So before I do anything, I'm going to go ahead and factor the denominators. And now that all of you are experts at factoring by now, hopefully this is a fairly fast procedure. So here's the factors for this denominator. And here's the factors for this denominator. So I'm just pulling out a greatest common factor in that denominator. And so now I'm just looking for, all right, well, what does this one have that this one doesn't have? And what does this one have that this one doesn't have? And so if I combine everything, I'm going to get as my new denominator 2 times x minus 7 times x plus 4. That has to be the denominator. I'm going to bring down the plus sign. And I'm just going to rewrite that denominator over here as well. So as we look at this denominator and kind of see, all right, well, what's it missing? It's missing a 2. So that means I had to have multiplied this denominator by 2. I'm doing the same thing to the numerator. Over here, this denominator is missing the x plus 4. So I have to multiply all of that by x plus 4. I'm going to do the same thing to the numerator. And I'm going to go ahead and distribute that 7. So this becomes plus 7x plus 28. And now I can combine the numerators. So I have 7x plus 38, just combining like terms there, all over all of this. And there is nothing to reduce here because I cannot factor that numerator at all. So this is the answer. I'm going to give you 2 of these to try on your own, and I will be checking these, so make sure you try them both, and we will talk about this in class.